Hello, everybody. My name is Roman Guy. I'm the team leader of a graphics team.
And I am Chet Haase, and I do a lot of meetings.
And we are here to tell you some random presentation about you and I. But actually, not really. The reason why we decided to make this silly joke is that our talk was really inspired by Chet and Roman Guy. They did an awesome talk, and actually we think that, wow, it could be nice really to go over the basics, what does it mean to render a pixel on the screen and what's involved in that. And Rafi...
More than that, Chet is sitting right here, and
yeah.
It's truly an honor to host him here in Ukraine, and we're thankful for him and a lot of other great speakers that came here. So big thanks and shout outs and everything. Can I take the shirt now?
I will stay. I like to be a Roman Guy.
All right.
Yeah, you always like playing his dumb, and the Chet is smart, so I like we're in the same position. No offensive, no. We're usually a very direct person. It's my excuse. So who we are, in case you didn't know, my name is Jonathan, or Yonatan in Hebrew version. In my life, I'm doing various stuff, but basically there is two. One, I'm running the startup in genetics field, and this is the opportunity to invite you to my keynote talk that will little bit touch what I'm doing on a daily basis. And besides, I have Rafael, is my co-lead for Android Academy, and he's going to tell what is Android Academy, right? Yep. So who you are, Rafael?
So hi all. I guess most of you know already Yonatan because he's here for every year for forever. What you don't know that he sucks at Fortnite, so that's it. And I'm Rafael, my first presentation in English, so cut me some slack, please. And I run a company by day called HeroApps. We do mobile applications development. And we have Android Academy, which is something I am co-leading with Yonatan forever, at night, at day. Yeah, and what we do, we're a big community that allows a lot of developers to learn Android for free. We have lots of mentors from big companies, Google, Facebook, you name it. And we've gone global.
Yeah, and this is the great opportunity to invite you. So we decide to spread over the globe. So we have Android Academy in different parts, actually in 4 different countries. And it's an opportunity to offer you, if you really feel passionate about the Android and you want to take it to the next level, come to us, talk. We really want to spread our knowledge, spread the free knowledge globally to all possible places where we can reach, okay? So don't hesitate, just come to us and we will find a way how to move forward. Take the clicker, come on, why I'm working hard every
always
time.
Gives it to me. Okay, so yeah, the title is like a mic drop title, but actually we have kind of limited time, so we decided to keep it simple.
Yeah,
what
so
we'll talk about.
The slides.
Okay, so you wanted to see the mountains. There you go. So we have mountains and rivers, and that's not our talk today. What we want you to take from this talk is we'll talk about what is a frame, how do we build it, what do we do with it, and how to know if you're doing it wrong or right. So let's begin. Why do we love apps? Yonatan, why do you love apps?
I don't know. They're working nice, animations. Actually, they work.
So animations. Yonatan likes animations, or when it works. So one of the things we like most is smooth experience. When you're working with an app and it's not smooth, it's janky, God forbid you're having an ANR, it sucks. And you don't want to see it. You want to have a smooth experience. So we've took some examples that we'll go over. So the Google Play Store, one of my personal favorites, because every animation there is inside, it has meaning. What does it have, Yonatan?
Smooth animations.
Okay.
Smooth.
Another personal favorite, I don't know if you guys know, it's called House. It's a startup located in Israel, and they are basically a community of guys and girls that love interior design. And their UX, their user experience is amazing. You can come in, you can download their app. It's not sponsored by any way. And they have a lot of features, yet it's so simple to use. So it's one of my favorites because they did an awesome job. What we know right now, what we talked about, is motion is key. Motion is everything. It takes your eyes and it just navigates you to the places that we, as developers or product, want to take you to.
So basically, you just say that meaningful animations, right? The one that guide you.
Don't just animate everything. It will just confuse you, the users, everyone. So, how is motion perceived? Let's go back in time and understand how the human eye works. So, the human eye can see light. That now I see all you guys because there's light that jumps on you and comes into my eyes and I see you. Now, how are we making you guys see it on a screen? So we're basically fooling everyone and we're making you see frame by frame. So when you're looking at a video, you're basically seeing frame, and your mind is translating it to like a video, to motion. So the most easiest example is the flipbook. You're watching a flipbook and you're like, the
animation is happening. Whoa!
Your mind is translating it into motion. Now, there's several types, which we'll talk about, but I want to make sure that everyone here know what FPS means. What FPS means, Yonatan?
We just like easy can explain you that. There is a gamers in the crowd, like me. Don't be shy, come on. Everyone is playing the games.
I can make the Fortnite joke now. There's a lot of gamers. Okay. So, FPS is frames per second. And here are some examples of like the evolution of FPS throughout the years. So there's like 12 FPS, which is like we just showed you a demonstration. There's the flipbook. After that, we sort of evolved into 24 FPS, which is basically the movies that you're watching in this theater exactly. So there's a layer of effects with blur effects that makes your eye think that it's not 24 FPS, which will look a bit janky at times. So with effects, we're making it look smoother. And there's like the holy grail of 60 FPS. Everyone loves it. Everyone want to use it, want to do it, whatever. All of our manufacturers of screen are using it. And there's above 60 FPS.
But above, like, nobody really sees it, right?
So there's like the huge World War III about it. All the gamers, which are a lot in the crowd, always like to have more FPS, more FPS. I want to have more.
There's more FPS.
Yeah, which is sometimes good, sometimes bad, because if you have FPS drops, it can mess up everything, and then you die like Yonatan. And you don't want to die like Yonatan. So
keep saying that I'm stuck in Fortnite. Like, okay, no worries. Thank you.
12 old kids are killing him. It's that sad. It's really sad. Okay, so no difference. Well, it's not true, because there have been many research about that matter, and many people are actually able to see and react to higher FPSs. But mostly the biggest problem here, I mean, it's when you drop. Because if you're having a high FPS, let's say 100 or 120, and your hardware supports it, it's okay, but it's also hard for you, performance-wise, to support it constantly. What matters most is to have a constant FPS. So that's the most important thing.
So, as a developers, where we want to be? Like, which spot? Like, should it be on the 100 FPS or like maybe 24? Because like,
right now, if you're developing for Android, unless you're developing Fortnite, you should go to. I personally, I'd recommend 60 FPS. Constantly.
I guess we have a slide for that, right?
Yeah, we do.
Yeah.
Boom.
Damn.
60 FPS is the king, unlike Yonatan, which keeps dying.
Yeah, okay. I keep saying that.
So we have 60 FPS. So that means how many frames are we supposed to show our user every?
Well, like.
Okay, so we are displaying a user a new frame every 16 milliseconds.
What, it's so, like how you calculate it. Like, what? You do the thing. Okay,
so let's talk about some real-life examples. So we want to show that screen. By the way, the screenshot is from an app called Played, which is made by Nick Butcher and some other contributors, which is awesome, and open source. If you want, you can check it on GitHub. And let's see. So we have a CPU. Everyone knows the CPU, right?
Where you should mine the Bitcoins.
No, you mine them on the GPU. But that's a talk for another day. Okay, so our CPU is like creating a new view for us. And a lot of things go as well. We'll see in a few slides. And now we want to display our new view on our screen, right? So say hello to our GPU, or in our story, Yonatan's GPU. He always has the best gear, and he still dies. Remember that. So we have our GPU.
At least I'm enjoying dying. Like, I'm dying with the 60 FPS and above. Down.
Okay, so we have our GPU, which takes polygons and textures and display them on the screen. So we have a display list created by our CPU, and with OpenGL, uploads and syncs this data into our GPU, so he can show it on our screen.
Wait, I thought that OpenGL just used on the computer games. Like what? Android? OpenGL?
Okay, so we have a display list. Our CPU creates it, and what's a display list? It's just a mixture of statements that can be interpreted by our GPU, so he can do other stuff.
So it's basically
by our OpenGL.
So if I understand correctly, it's basically the list of the instructions for the GPU to draw on the screen using the OpenGL technology, right?
Exactly.
Wow, I'm smart.
OpenGL. What is OpenGL? Well, it's a cross-platform. Everyone uses it. It's basically a cross-platform, cross-language that we use to to render 2D and 3D models into our graphic cards. So now that we know what OpenGL is and display list, let's go back to our problem. What is our problem? Our problem is time. Because remember, we said we have to do all that, which doesn't look like a lot, I know, but it is a lot. We have to do all that in 16 milliseconds. So all of that work we have to put into 16 milliseconds.
But what work? Like, what exactly were you doing? Why you like so put it back?
So we're measuring, right? Every view of us that we create has to be measured. We have to lay out it on the screen. We have to draw it. We have to seek and upload it. We have to execute it. All of those things takes a lot of time, and we only have 16 milliseconds. So the last thing that we do, we create a frame buffer. We upload our data to that frame buffer, and it then displays on the screen.
Wait a little bit. I'm a little bit confused. Like you said that sync and upload, execute. What does it mean? Like I thought like it's just like on measure to measure the size of the view, on locate to find the right location on the screen, and then just to draw on the screen.
We're doing all that stuff, and then we create a buffer in the GPU memory, and we tell him, okay, now play, show us. And we'll talk about it in a second. So we have a frame buffer that loads our graphic, and now we have to display it, right? So Yonatan is with his Go.
I can't believe it.
And I hacked him. That picture wasn't easy to get. So Yonatan is with his girl, and he's playing Fortnite, and his child is winning, and he is dying. So he's playing a game, and this happens. Now, take a closer look on that picture.
What's wrong with it?
And what? So, there's a bonus question. Anyone in the room know what game it is?
What? Yeah.
What? No, that's right. But I asked, what game is it? Okay.
Already someone said that. What's your name? So no, he playing a lot of games. Managers in the room? These managers? Okay. Too many games.
So the game is Dead Rising, and now we have to understand our hardware.
Now, actually, can you explain what went wrong? Like, what was
Let's go back to the image. So you see that like the line and the top of the image is like cut out. See it? Anyone doesn't see it?
Someone not seeing that? Need glasses? I can.
Okay, cool. So let's try a little bit and understand how hardware works, so we can like analyze and understand the problem. So remember this whole thing? Anyone had it back at home other than me? So we have an old CCTV, and we're seeing the white screen of death, and that's 25 FPS. Now, that's the normal state of the television. Now, let's take it a little bit slower to understand what we're looking at when we see a screen of death, like the white screen. So that's our screen, how our screen works at 600 FPS. So we're basically seeing what happens, and you have to understand that every frame that you see at your screen, basically our hardware is drawing it from top to bottom. And it starts at the left side, and it's just drawing it at lines. Now, nowadays, if someone here knows this stuff in hardware, there are screens like the new smart ones that are working differently, dynamic screens and stuff like that, but most of our hardware is basically done that way, so we'll focus on that and not get you mixed with other technologies. So we're drawing our pixel from top to bottom, and you guys like Mario? Everyone does, so let's go even slower, like a ton slower, and that's Mario on the television on, I don't know how many frames, that's definitely a lot. By the way, there's a good explanation of the entire thing on a YouTube channel called Slow Mo Guys. They're awesome, and they made an amazing video about it.
I have a question. So meaning like, if I have a lot of really number of frames per second, is actually not really good?
No, that's not frames, that's just capture normal TV. You're basically seeing 25 FPS, but they pictured it with a like super smart camera, and they made it look slow. So you can understand how it works. Cool. So what actually happens in our games? So we have the CPU and the GPU, and the pink one you see on the screen is like our frame. And then we're just starting to draw our new frame. And at the middle of our operation, the system takes our frame and displays it on the screen. So that's what happens when you see the cut. We draw a new frame, and then it got passed away. So what's the solution, Yonatan?
Buffer? No?
Okay,
yeah,
so the solution is double buffer. So with a double buffer, we have a back buffer and our frame buffer. And when we create a new buffer, we first create the back buffer, we finish building it, and when it's done, we copy it to the frame buffer, and that's the one that gets passed on to the screen. So
I have a question. Isn't create some certain of like performance issue because you're putting everything in some sort of queue, right? Mm-hmm. So you need to work really, really hard to switch
we'll talk about it a little bit more in a few slides, but essentially, if you're not finished with the next frame, you get stuck and you lose the frame. And then you see the choreographer gets mad at you.
I heard that Chet and the team that develops thing that called rendered. Can you... We have a slide about it.
Chet wrote it alone, definitely, and it's called
like Chuck Norris.
Okay. So there's a little thing called render thread, which is if you're like me and you're working on projects that you choose, you get the privilege of deciding that you're aiming only to Lollipop and above. So if you're like me, then
you're a lucky one. Because most of the people not like you.
Yeah, so if you get that privilege, fine. If not, well, the render thread is only Lollipop and above. And what does it do? Well, it do a lot. It's doing a lot. But basically, the render thread is just, it took from the UI thread all the responsibility of talking to the GPU. So all GPU like handling moved to the render thread. On top of that, the render thread can do some sort of cool things like animations like circular reveal. It can do atomically on its own without involving the UI thread. So we're taking some kind of work off the main thread. So it basically helps us achieve that 16 milliseconds even easier.
So what does it mean? Does it mean that I can make the network request on the UI thread?
Well, if you are Yonatan and you do whatever you want all the time, so you can do you can do it, but me and probably them, no, because we have to follow certain rules. But we also don't die at Fortnite, and you do. So that's also something.
So let me understand it correctly. I thought we have the render thread, right? Mm-hmm. And we have this work that actually was outlawed to the separate thread. We still bound it to the 60 milliseconds to draw the frame for the 60 FPS on our UI thread. Mm-hmm. And we can block it, right?
Yeah. Never block the UI thread. That's like a rule of thumb. So, as you can see in this slide, there's a lot of things that's going on, and we won't talk about it extensively and deeply in here, but there's a great talk at Google I/O 18 called Drawn Out. Google it. You will really love it if you're interested in the subject. Let's move on. So, tools.
Yeah, so we spoke a lot about what possibly can go wrong, like what is happening under the hood. The next question I always have in my mind, like, okay, I get it, understand the reason why it's happening, but how actually solve it? And how there's a lot of different tools. And I remember when I was playing with Android Studio, there was a bunch of tools, and one of them was the layout editor, I think, right?
Yes.
And when I ask you, explain to me that actually the first problem that starts with losing frames is actually when you have very complex views, right? So we have complex views inside the complex layout, and then actually the first thing that you're gonna look when you have frame drops in your app is actually how complex are your layout. You have the nested, I don't know, constraint layouts with the children's and the scroll inside of it, or what. And there is a tools that can really help you to easily navigate what actually happened inside of your app and how you can solve it, and it's called Layout Editor, Layout Inspector, sorry. Yeah, because they're always in the Android Studio team, they're changing the name, so it's very hard to follow them. Look something layout and you will find it. Do these things, yeah. Yeah. Can you do it again? Give me this. Give me it. Just give me. So yeah, the point of this tool is actually to find out how your view is built. So you can go over the whole layout to see actually how it's translated to the view, how it's translated to the hierarchy inside your app, and actually what you can improve in order to make your CPU work less to compute how exactly going your views looking on the screen. You remember the CPU doing a lot of stuff on the UI thread. It's like try to find where the right spot to put the view, right? They try to figure out what the right size, and actually it's try to draw on the screen.
I'll give an example for that. Let's pretend you have this big app, and it's really, really big. You have a lot of screens, and most of the time there are many developers that are working on it or worked at the past. And now you have an XML file which looks like a relative layout inside a relative layout, inside a linear layout, inside a, and it keeps going and on and on and on and on. Now, if you're just looking at the XML, maybe you won't see the bigger picture. But if you're using a tool like that, it's easier to understand what's going on, and then you can see where can you do it more efficiently.
Right. Thank you, Rafael. And there is another thing there. So we will find out that there is a complex layouts, right? So there is a lot of things that should be improved. Besides there is a lot of other issues that can be involved in the complex layout. And what are there?
Overdraw.
Cool. Yeah. So what does it mean, overdraw? Overdraw means that we have a couple pixels that draw one on another, right? So we're basically just drawing pixel and not showing them. We waste time of the CPU and not using that. We just like throw our work for free. I want to understand actually how it's the work overdraw.
What?
If you want to understand, I will give you clicker back.
Okay, so basically overdraw, most of the time are pretty well covered, because if you're using like the Android system parts, most of it is being handled by the system. But if you're creating a custom UI of your own and you're doing an override to the onDraw method and doing like lots of stuff that are custom in your app, in your design, so you do have to pay attention to what you're doing, because you can do some stuff that are really, really bad performance-wise. So, okay, so let's take an example let's look at the example that we've provided. So we have a list of cards, and some of them are being shadowed by the front one. So it's being covered. Now, what's our problem and what is overdraw? This is overdraw. When you're having a visible card and all the stacks behind it are still being drawn. So they're drawn out, and it's not very efficient.
I thought the chat teams already solved it somehow, no?
They solved everything.
Chuck Norris.
Okay, so detecting overdraw is pretty easy. You just go to the developer options, in case you don't know how, and you select show the overdraw areas. And then what do you see? That's what you see. The entire screen is being like colorful as hell, and there are a lot of colors. Now, what does the color means? So if you have blue, you're at an amazing situation.
I like blue.
Yonatan is always blue. That's why he kept the shirt. So blue means really, really good. Red is really, really bad. Now, in case you're developing an app and now you're testing it right after you walk out of it, and there's a lot of red, don't be that bummed about it, because even the big guys still do it. It's a constant effort to make things better. Let's look at an example. That's Facebook, for example. So even the big ones have issues with it, so you just have to look at your code and try to see where you can do things better. Right,
so I guess
Yonatan?
there is a lot of different things that you can do and actually to improve it, right?
Yeah.
So can you walk us through those things?
Yes. Well, there is a common issue that I, as someone that constantly see different projects, because I own a software company and a lot of my clients are, here, take this code. I have this developed already. So I always see like unnecessary backgrounds. I don't know why, but it's like a disease. Everyone just puts backgrounds everywhere. This linear layout is transparent, has a background that is transparent, and he has a child that also has transparent or with some kind of color, like blue, 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 blue everywhere. And what it means for the system is that we keep drawing blue on blue pixels. So we keep doing stuff that are unnecessary, and it's not good for our performance.
So besides knowing this unnecessary thing, so are there anything that me as a developer can do? Like,
well, yeah, in case you're doing like a custom UI and you're overriding the onDraw method, you have to pay attention to quick reject and clip rect. You can avoid a lot of issues.
I guess we have a slide about it, right?
Yeah.
Yeah,
so,
quick reject.
We won't go too deep into it, but quick reject means you can just quickly, like the name said, you can quickly reject this view and like ignore the bounds. And clip rect, you can just set a rectangle and just tell the system that only the stuff inside it is what you want to see, and the rest is being ignored.
So let me just to recap it if I understand it correctly. So basically, the quick reject, I can calculate if this view is going to be visible or not, and then actually by using this flag, I can actually tell the system that we don't need to draw it, right?
Yeah.
And the clip reject is just to measure the boundaries of the view, so the view partially hidden, right? And I want to draw everything, I can just draw the part of it, and then to save my CPU from doing the rest of that, right? Am I right?
Cool. You should have the GIF of I am the smartest man alive right now. So the next tool that we're going to cover is the GPU profiling tool. Anyone knows it? Used it before? With a raise of hands? Oh, we have a lot. Cool.
Yeah. How many have actually really used it for purpose? Cool. Okay, cool. So this is part for you. Like, you know it's there. It could be really useful if you understand what exactly you see there.
Okay, so the GPU profiling tool, like we showed earlier, it can be accessed from the developer options, and then you just click on screen as bars, and what you will see is this. So don't be alarmed. Remember, we talked about the 16 milliseconds. So at the bottom of the screen, you can see like a green line. That's the line of the 16 milliseconds, and the screen will move. The bars will go high, low, whatever, and it will constantly keep moving. And what you're seeing, the bars, they have like different colors, and every color has a meaning, and when you pass that green line, it means you went above 16 milliseconds. So you skipped a few frames. So then, us as developers has to understand what's the problem, what's the issue, and then fix it. So,
I think we can connect these lines to the previous slides that what we explained about how the view again is actually rendered on the screen.
Yeah, we have a demonstration pretty soon. So we have shiny colors, and what do they mean? So I'm going to ask Yonatan, because he still wears the Roman Gui t-shirt.
Roman Gui.
So,
what, you want me to explain it?
Yes.
So give me the clicker. So basically there is a bunch of things that are happening on the screen. So if I look up, take you to back, you see there is a lot of green. Okay, what does it mean green? It probably the problem with the vsync or input animation and measure layout. It's just not look very well. But I will walk you from what exactly every step is meaning and what exactly could be possibly fixed in your app in order to not be in the spot where you're losing the frames and make your user delightful. So the whole thing starts with the vsync. So you already know the vsync, the thing that you're looking on the two different pictures, right? The one that was switched before actually it was ready. So this is the thing. You have different frames and they change one another, and actually when you're losing a lot of pictures, then this is the problem that happen, that you work a lot on the UI thread, you start to lose the frames, and actually your buffers are not working really properly, and you will see the different issues with that. Then actually you have a choreograph. Oh, I missed this part.
Yeah, we just talked about it, so it's said, okay.
Yeah. So
we talk about the choreographer here.
Yeah, so the choreography is actually, it's the one, for me for a long time, it was like, I don't understand this line, so why it's always snagging me in the logs. But actually it's there for the reason, just to warn you that you're losing the frames. So actually when you're going to show any animation to your user, it's going to suck because you're losing frames, and Android will not able to really draw every possible frame of this animation, because actually you're spending too much time wasting CPU or something else, like, I don't know, showing kitties or other stuff. And then we have the input is the green line. So if you spend a lot of time on UI thread dealing with the input, have no idea why it's green, but like maybe Chet know. So you probably need to start to optimize the dealing with the input call, like processing the click on the button, right? So the common mistake is like someone click on the button, so you have this listener, and you start to have this stuff on the button clicking, but you forget that actually you are still on the UI thread, and you are processing the input event too much time. Then you have the animations, right? So you're spending too much time on animating something. Like a really good example could be that you have a custom view, and you have the Overdraw method, and you're doing something very heavily extensive calculations on the Overdraw, like I did. Once I create the view with very hard animation, that I was calculating the arcs of this view. I was drawing the circle, so I was doing the extensive math in the Overdraw and actually allocating new paint and all this stuff inside the Overdraw. So this is actually the one that you need to check really, really closely. Measure layout. So you know the layouting thing. If you have the complex layout, probably you need to look that. More than that in a few slides. Really? Okay, so you're going to explain because I don't have no idea. Draw, so, whoa. Probably the thing that you invalidate the view too many times, so it's going for draw too many excessively, so even for the same view a couple times in the same frame, so it's basically just calculating on draw again and again and again. Probably by the way, one of the things that you can check if the view is changed, like the state of the view changed, and if this didn't change, to save the old calculations, like to cache the calculations before and actually then to use them in your Overdraw method. Single upload. Can you explain? It's
we talked about it.
Yeah, so it's like running a lot of drawables one to the other. Mm-hmm. So like one of the common mistakes like you have when the designer come to you and say, hey, I have this fancy animation, and you say, hey, I have like 2 weeks to implement it in Android. I thought an iPhone is like 2 days. One of the solutions may come is like, okay, I will create for you like 60 images, just run them very fast. And then actually you can run this problem, like single upload. So you have too many images to process and show to the user, so you can spend too much time on sync. Common issues is like, well, I don't remember what exactly. Can you explain it?
Well, if you have a complex view and you're doing a lot of rendering, it can happen. You have a lot of invalidations that aren't really required, stuff like that.
Cool. And the swap buffers, so...
Basically, it means you have far more work on your GPU than you're supposed to have. You have to understand why. Maybe you have like big images that keep coming, animations. If you're doing sequence of animations that are way too heavy in full screen mode.
Cool. So what do they mean?
What do the colors mean?
Yeah, I have an idea.
So now we know, and when we look at that screenshot, we can see that we have a lot of green, and then we can go and investigate what do we have to fix.
So probably I'm going to ask guys from Facebook to look on the measure layout and animations thing, right?
Maybe I don't want to go on them too much.
The F company.
Okay, so another tool we can use, which is one of my personal favorites, is the Vitals dashboard. you have a lot of amazing data that are being collected and displayed there. One of which is batteries. Personally, I really like to see the information about the permissions. If you're using runtime permission, if you're asking from users, you can see in percentage-wise how many of your users are declining and who accepts, stuff like that. It's really interesting and can make you create a better product. Aside from that, rendering, you can see like a dashboard in the vitals, which is, by the way, it's in the Google Play console. So you can see amazing data about your application, about your rendering times, hot open of the application and cold start, hot start, stuff like that.
Yeah, and can you? And the really big benefit of that is actually when you test on your device at the office, at the home, you actually test on only one device. And as we know, there is a lot of different device fragmentation. And Samsung phones, S phones, and the H phones and other manufacturers, each one of them actually possibly can implement the drawing on the screen differently. So your app can be really completely work amazing, fine with the 60 FPS on Pixel devices and completely suck on the Huawei devices. Why? Because they're implemented something different for this particular version, and then you can need to look on it closely. So the vitals can really give you the overall picture of all devices that you have. Like actually the users that using your app.
Since you already talked about it, we have to take another thing into the factor here. OS. Some of your users have Android 6 installed, some of them Android 8, some of them are below Lollipop. So it can vary, and we have
it was signed that we need to finish.
Yeah, okay. So what do we talk about today? We explained why 60 FPS. We talked about the stages of creating a frame, and we went over some of the tools that we like that can make your life easier.
And personally, I want to finish with a thing that we all working under time constraints, right? So there is a balance between we need to develop this feature as fast as possible, right? Because there is time to market, and we have our managers, CTOs, CEOs pushing our buttons. But it's only our responsibility, actually, how the app going to look. And this effort that we just showed to you, first of all, you're aware that what you need to do, you know how to do, and actually it's up to you how are your users going to perceive your app. It's going to be amazing animations, very working smoothly, or, you just be another app on the Play Store. Thank you very much.